Chapter 5, Section 5.1, Example 1, Finding Explicit Formulas. So for each of the following sequences, find the explicit formula for the nth term of the sequence. So here we're not looking at summation or anything, so that's the difference between sequence and series. This one's just a sequence of numbers that we're looking for a general term for, or like a definition. So let's see what we have here. First thing I notice is that it alternates from negative to positive. So we know that it's going to have a -1 somewhere in here. It's a -1 raised to the nth power. And let's see, so for the first term, n is negative. And for the first term here, n is going to be negative as well. So we took care of those signs here. All right, now for the actual value. So I see a 1/2. And then a 2/3. So it looks like we could say that n, or the numerator, is going to be n, and the denominator is going to be an n plus 1. So 1 larger than the denominator. So 4/5, 4 is smaller than 5, and those are two consecutive numbers. So here our term is going to be n over n plus 1. So now let's start looking at the terms. So for the first one, it's a -1/2. So we have -1 to the power 1, and this is going to be for the first term. So -1 to the power 1, 1/1 plus 1. So that would be a -1/2. So that one works out. Let's look at, that's the first, second, third, fourth. Let's try the fourth one. So here n is going to be equal to 4. -1 to the power 4, 4/4 plus 1. So that gives us a positive 4/5, which is exactly what we have here. And there you go. There's that first sequence. Let's take a look at this second sequence. All right, so all of these end up being positive, so we don't have to worry about the -1 in the front. Let's take a look at the numerator. So the numerator looks to be powers of 3. So we could start with that. We'll say 3n over, let's see. So 3n up here looks good. Down here we have 4, 7, 10, 13, and 16. It looks like we're adding 3 to each of these. So 4 plus 3 gives us 7. 7 plus 3 gives us 10. 10 plus 3 gives us 13. So it's going to be something plus 3. But what is our starting point? So 1. Let's see, we'll say n. So n plus 3. 2 plus 3 ends up being, actually no, so it would be multiplied by 3. So the common difference would be 3n. And let's see, in order to get to 4, we could do plus 1. In order to get to 7, 2 times 3 is 6, plus 1 is 7. And let's grab the entire term and look for this one here. So that's 1, 2, 3, the fourth term. Let's give that a try. So our goal is to end up with this right here. And let's see. So we have 3 to the power 4 over 3 times 4 plus 1. So 3 to the power 4 is 81. And then we have 12 plus 1, which gives us 13. So we have 81 over 13, which is exactly what we have here. And there we go. So this is a general term for this sequence, whereas this is a general term for this sequence. And that's it. If you have any questions, please feel free to ask. Otherwise, bye.